Hi, my name is Derek Weitzel, and I'm a research associate professor here at the University of Nebraska-Lincoln in the School of Computing. And I want to talk to you about my project, teaching an AI agent to drive a supercomputer. So a little background about the Holland Computing Center. So we are the research computing core for the entire University of Nebraska system. We operate the fastest computing resources in the state and make them available to every institution in the state for no charge. So we have over 1,000 active users, 26 petabytes of storage. One of the major clusters that we run is called Swan. It's our newest Linux cluster. We have 160 CPU nodes, 40 plus GPU nodes, and it runs the Slurm scheduler. It provides free access for everybody. Holland Computing Center also employs about 20 staff, including system administrators, application specialists, and DevOps engineers. And we help researchers port and parallelize their code. So again, we are the central research computing facility for the entire state of Nebraska. So every campus in the University of Nebraska system. A little bit about me and the co-sponsor, Natasha. So I have been at Holland Computing Center since about 2006. I build and operate distributed computing and data infrastructure worldwide. I work for the OSG Consortium, Open Science Data Federation, and National Research Platform. Natasha has about a decade of helping researchers scale compute-intensive workflows. She also works at the Holland Computing Center, and her background is in computational genomics and high-throughput uh, bioinformatics. So a little bit about our project. So how does researchers use our research computing these days? So the first step is they log in, they write a script, usually they hand author it. It's usually like a bash script with Slurm, and you have to have the right flags in order to submit the job correctly. And then you submit the job, and then you babysit the job. You watch the queue, you look through logs for any errors. We have some things that'll help out a little bit. We have Open on Demand, which is HCC's web portal. It gives kind of a browser-based way to submit jobs and manage files, and it removes the terminal, but the user still has to know what to ask for. They still have to read documentation. And what's missing is there's no agent accessible interface to the cluster. So every path in and out is a human clicking and typing, and the AI agent can't orchestrate an HPC workload at all. My goal, my dream, is to have a researcher that says, I've got 200 protein sequences in this directory, fold them with AlphaFold, which is a research computing application using a GPU node, and email me when they finish. And then the AI would go look at HCC documentation of how to access AlphaFold, how to submit a GPU node. It'll compose the submission script with sane resource requests because it knows kind of how AlphaFold works. And then it'll show it to the human. It'll say, okay, the Swan has a bunch of GPU nodes. AlphaFold 3 is available as a module. Here's the batch script I would submit, and it would present that batch script to the user and its structure. And then it would say, are you sure you want to go ahead and submit it? And the user would say, yep, looks good, go ahead. And then it'll submit it and watch its status. So I want the human in the loop to approve the final submission, but I want to be able to use natural language in order to actually write the submission file. So a little bit about how I think this would be implemented is the Model Context Protocol. So it's an open standard for exposing tools and data and actions to agents in a structured way. Write one server, and any client that can use MCP servers can use it. So Claude or ChatGPT or an open weights model with a harness. So the MCP client, which would be the open weights, the harness, decides what the user wants and which tool to call. The MCP server actually declares the tools, validates inputs, enforces the policy, and then it will SSH or go into the cluster and actually run the real command, real cores, real GPUs, real queues. So the point is this MCP server that can drive an HCC cluster. So the MCP server has to have these three different capabilities. So first, that user should be able to ask about the cluster. It should understand documentation that we generate. It should report available software modules and explain partitions, limits, policies on the cluster that it can detect. It should also be able to compose and submit a Slurm script to actually submit a job to the cluster. And then once the job is submitted, it should be able to watch the job, uh, get standard error, standard out, and logs, and be able to cancel and modify jobs to do some basic debugging if a job fails. And to be sure, this is all from the user perspective. I don't anticipate any administrative use of this MCP server. So no changes to Slurm, no changes to billing systems, no GUI. This is just an interface, agent-facing interface. And I want to emphasize that this solution space is wide open. As far as I know, there's only been one other prototype for this from Purdue that did some similar things, wrapping Slurm, storage, and docs index. And it's something to learn from. But I want the students to feel uh, empowered to create their own solution to these problems. How to do uh, tools creation and submission, how to scrape the documentation, how to prompt the agent so that it asks for permission at the right time, how to handle authentication to the servers, and how to evaluate is this agent working as it should be. And of course, I want to emphasize the safety part. So an agent, these research computing resources are large. They have lots of bandwidth. They have the capability to do harm, and I want to be able to keep a human in the loop in order to approve anything that takes a real effect on the cluster. For example, submitting a job. So, an agent should propose a job script. The server may validate it and for the syntax and maybe do a dry run of it. But in the end, a human should approve the actual submission of the job. So you have to worry about the user authenticating with the cluster, how to constrain a user so that they're not going over their limits, and to be able to provide feedback back to the user if they are. And then be able to have every tool logged so that HEC staff can know, okay, what did this agent just do? So if I had to, and I want to emphasize that the students are able to come up with their own creation, but if I had to implement it in my own head, I would use official agent SDK. There's many of them out there for the model context protocol. I would write it in something like Python. Of course, it would have to interact with our cluster, so it would have to interact with Slurm. For the agents, I would use open weight LLMs, which we will provide, that are frontier model, but also able to use without worrying about costs or limitations. Testing would done through some sort of Python testing, and then we would use GitHub for our collaboration. And so you would actually be testing on the real cluster, being able to submit jobs and be able to parse our documentation in order to have the agent and the MCP server actually handle the submission. So deliverables of what we expect in the end: a working MCP server, two example workflows, like for example, the example workflow in the beginning of this presentation where I talked about AlphaFold. That'll be a great example. A test suite, a security design document. The reason I want this security design document is that this is giving a lot of power to the agent. And I want to be able to make sure that you're prompting the user at the right times, that when the agent is logging into the cluster, it's doing it appropriately. And then, of course, a live demo to HEC staff, me and Natasha primarily, of this agent doing the work. So why is this worth your time? We want to lower the barrier of entry to research computing at the University of Nebraska. So we want to be able to have a biologist that's never opened a terminal be able to run a GPU workflow, be able to use natural language to access our petabytes of storage. And I want them to spend less time finding the scheduler, looking up documentation, figuring out how these things work together. And for HCC, we want an auditable API layer for the cluster, easier enforcement of resource policy and usage tracking, and hopefully a path to serving a whole new class of users with a lower barrier of entry. And of course, for you, this is really a novel system, something that MCP servers are becoming more and more common for all applications on the internet and across the world. And we want a demo that you can show to your hopefully future employers to say, I've worked with AI. I've created this MCP server to steer this agent in a certain direction, and I understand how these things work together. So how we expect to work together? So we expect weekly or biweekly check-ins in person or over Zoom or Teams. I would hope that frequent email conversations or questions from the students to the sponsors or other people that may need help. Well, HCC staff, myself, Natasha, and other people in the Holland Computing Center will be available for Q&A at any time. And we are in Lincoln, so we can, of course, come and actually meet in person. I expect giving a tour of the Holland Computing Center at the beginning of this project, and we can always figure out all these details at first. And we're looking for students who are comfortable with like a Linux terminal. You can read and write Python. You're interested in designing a system rather than just kind of bolting onto one. And you're curious about AI agents and real infrastructure and how natural language can be used to drive real infrastructure. Now, we don't expect any prior HPC or Slurm experience. We will definitely teach that in the early parts of this project. So please come build with us. We really are excited about this project, and we hope that you are as well. Thank you.